co-founder and head researcher at Semiotic Labs to talk about something really exciting in the graph ecosystem, where GraphQL has been the main language for querying for years, and Sam's going to talk about how to bring SQL into the graph ecosystem. So come on up, Sam.
Hey everyone, thanks for being here this afternoon. I know some of you are dealing with jet lag, so I appreciate the push. So my name is Sam Green. Could we go to the first slide, please? Yeah. I'm with Semiotic Labs. I'm a co-founder and head of research, and Semiotic is a core dev in the graph. And today I'm going to be sharing with you our progress in bringing SQL to the graph as a new data service. First, I'll talk about subgraphs and GraphQL. That's what the graph currently does today. I'll then introduce substreams, and then I'll introduce OLAP databases. OLAP databases are good for analytics queries. And then I'll talk about our work with syncing substreams to a particular OLAP database called ClickHouse, which is great. It's really great for analytics queries. And then I will give a demonstration of a tool that we're building on top of the graph stack for doing natural language queries that map to analytics queries. So if you've heard of subgraphs before, that's because of the graph. And subgraphs specialize in generating or providing GraphQL endpoints. And today, most of the biggest apps, they use GraphQL for their front ends. And if you've never seen GraphQL before, this is what it looks like. This particular query is for the Uniswap v3 subgraph, and it lets you access, when you run this query, it gives you the latest token pair that was created. And when I ran that query last night, I saw that this token pair was the most recent pair, Pepe Wealth and Wrapped Ether, and I also asked for how many fees had gone into that pool. And typically the way it works is you generate the GraphQL query that you're interested in, you then basically embed that in, you call that query with JavaScript, and you put that query on your website, and then when someone visits your website, they get this custom endpoint for the data they want. So this GraphQL is great for dApps, it's great for front ends, but it's not great for analytics uses or ad hoc querying for data. So Sevi, a few minutes ago, he was talking about Firehose. Firehose then flows into substreams. Substreams is a technology that is built by another one of the core dev teams in the graph called Streaming Fast. And as a refresher, what Firehose does is you basically instrument a full node on whatever chain you're interested in. That could be an Ethereum-based chain or a non-EVM chain, and it provides a unified format for data that can then be used for downstream applications. And what we do is we have a tool called substreams, and substreams basically read from these Firehose files, and then you can do transformations with these substreams and basically do whatever you want to do with that raw data that's in the Firehose files that are output. Substreams modules are awesome because they're composable. So if I write a substream module that, let's say, I extract all of the Uniswap data, I could then post that substream and share that with you. You could then take what I did and you could build further transformations on that data. They're also parameterizable. So let's say I write a substream for ERC 721s for NFTs, and you wanted to watch a particular NFT, then you could use my substream and just tailor it for your application really easily. They're also transformable, so let's say you can do transformations within substreams. So let's say you wanted to calculate a moving average of some, let's say the ETH to USDC ratio. You could easily do that transformation within the substream and then use that output for downstream applications. They're also parallelizable, so you can, these flat files are just binary files on the machine, and you can read from these binary files in parallel, so you can get the data that you need extremely quickly. And the final low-level detail is that they're written in Rust. Substreams are written in Rust, and that Rust gets compiled to WASM, and then that WASM gets sent to a substream service that then processes the flat files. So again, we have the Firehose. Firehose extracts all of the data into a binary format for every chain that we support, and our goal is to support every chain that has significant activity, and it puts it into a unified file format called flat files. Those flat files can then be read with substreams, and then substreams are very customizable, and you can send the output of the substreams file wherever you want. You could send the data into the backend for a database for then querying with subgraphs. You could send it into a CSV if you want, a spreadsheet if you want, or an ARC application, we're sending it into a database for querying with SQL. And this is what I just said in a visual way. So you write your substreams module in Rust, it gets compiled. You write your substreams module in Rust, and then it gets compiled into WASM. That WASM then gets sent to this thing called a substream service, which sits alongside these binary flat files, and they can quickly process the data. And so you can write substreams modules for GraphQL applications. This is what we would call substreams-powered subgraphs. You can write it you can sync the data straight to a database for querying with SQL, or actually you can also just stream the data out in real time. And today, in the past, we had some applications that had extremely high transaction volume, and this was difficult for us to deal with the V1 graph. But with substreams, powered subgraphs, we can now handle the highest volume dApps. Okay, so now I'm going to transition the talk into focusing on the SQL and the SQL data service that we're building. And when we first started this work, we evaluated both OLTP databases, which is what we were currently using, which we were using in the V1 stack of the graph. We were using Postgres, and we started looking at OLAP databases. An OLTP database, that's what MySQL is, that's what Postgres is, and this presentation was converted to a PDF, so this isn't showing, the animation isn't showing, but with an OLTP database, what has to happen is you have to read, whenever you do a query in an OLTP database, it has to read every row of the database. And then you could extract certain information that you would be interested in. So for example, if you were just interested in doing analytics related to time, location, and mobile phone data using an OLTP database, you'd have to read 100% of the records that you were interested in and then extract the time, location, mobile phone fields from that. So OLTP databases are this is the cost for OLTP databases for analytics applications. You have to read all of the data. Whereas with OLAP databases are column-oriented. And so when you do it, they're optimized for reading columns of data. And so if you want to do any analytics on this time, location, mobile phone data, you can query just the columns, and you don't have to access all of that yellow stuff. You don't have to read all of the yellow stuff. So it's extremely fast for analytics applications. Typically, OLAP databases are used more for businesses that are doing analytics. So we have picked a particular OLAP database after our evaluations called ClickHouse. ClickHouse has an Apache 2 license, and it works well with the licenses of our current stack. And we are writing substreams. We've been writing substreams to sync to the ClickHouse OLAP database. And now, if you've been in the earlier talks, you've heard us talking about extract, transform, load, query. And so with our ClickHouse solution, with our substreams ClickHouse solution, we extract the binary data or the blockchain data using Firehose. We filter the Firehose data with substreams. That data then gets synced to ClickHouse. And it's very quick to process data using this flow. So for example, we can index, on Ethereum, we can index all Uniswap v2 events from the launch of the v2 contracts and have it up to chain head in 4 hours. We can index all Ethereum ERC20 events from the time ERC20 was made available in 12 hours, and we can process all Ethereum blocks, the summary information from all Ethereum blocks in 19 hours. And here are some timing comparisons that we did. When we were doing these evaluations between the OLTP databases and the OLAP databases, we indexed Uniswap v2 and all of its clones on Ethereum, and we mapped the English questions that you see to SQL, and we optimized both MySQL and we optimized ClickHouse to compare the differences in query speeds. And in general, we see about a 10x speed increase for our queries with ClickHouse. So for example, the first question, what addresses bought the most ETH last month but did not sell any? That took 167 seconds in Postgres and 14 seconds in ClickHouse. Another question was, what token has had the lowest USD volatility? 17 seconds in Postgres versus 3 seconds in ClickHouse. And finally, what is the most popular DEX? That gave us a timeout in Postgres, and it was 12 seconds in ClickHouse. We are doing all of this work comparing these databases because we are going to be bringing SQL as a new data service to the Graph protocol. So in the future, you will be able to not just send GraphQL queries, but you'll also be able to send SQL queries to the protocol, and you'll be able to start building analytics applications on the Graph, which means you'll have the ability to build basically applications that unstoppable analytics applications on the Graph. And this, of course, is going to unlock new types of applications on the Graph. We'll be able to see analytics, market research applications, visualization tools, dashboards, block explorers, compliance, and anti-fraud tools. These are tools today that you could technically build using GraphQL, but it is not very efficient to do this with GraphQL and the V1 stack. But with SQL, this will become, the Graph will become very good foundation for these sorts of products to be built. And I think one thing that's exciting to me as being a core dev for the Graph is that what I think is interesting for the Graph for these use cases is that there are going to be many people that are going to be interested in the same data. Let's say Uniswap. You could probably list 5 tools right now that are tracking Uniswap transactions or Uniswap volume. Well, a lot of these solutions are basically, they're creating their own indexers and they're putting the data into the database, their database themselves. So they basically rolled their own analytics solution. But with the Graph, as soon as somebody has done it, it's already there for you. And so if you want to build a new product and you need this data that's already out there, you don't have to spin it up yourself. So that's going to basically give us this, you're going to be able to amortize the cost of your data because for these popular data sources, because of all these other people who have been interested in this data. So this is going to basically, you're going to be able to drive down your infrastructure costs a lot by building on top of the Graph, building these analytics tools on top of the Graph. You don't have to maintain these huge databases yourself anymore. So we have basically been dogfooding this new stack, and we're trying to build this new stack in a way that it's going to be compelling for other people to build analytics applications on top of the graph. So we're building Semiotic, is building an application on top of substreams, on top of ClickHouse, and we're also, this particular application or this tool that we're building uses natural language to then make it easier to access, write SQL and access the blockchain data. And it's called Agency. Could you start the video, please? Oh, actually, before you do, let me give a quick explanation of what you're about to see. So I'm going to give you a demo of Agency. And Agency is a tool for using natural language to access blockchain data. And initially, we're starting with DeFi as the use case. And eventually, we'll expand to all blockchain data. So don't think of this as just a DeFi tool. And the data that we have currently done is we have Uniswap v2 and all of its clones, Uniswap v3, and Uniswap X. So we have access to all of that data. And so that constitutes, I think, about 15 different DEXs. And this is and it's only on Ethereum right now. So press play, please. So you go to Agency, and you can type a question in natural language. So here I'm typing trade volume today for all DEXs. And what's happening is that English is being sent to the back end. It's being converted to SQL, ClickHouse SQL, and then it's returning the results and showing you the results. In that table that was just shown, it didn't format the numbers as dollars. It was just floating point numbers. And so here I just typed in, show me, or format the table with USD. And so here, if you look in the right-hand side of the screen, you'll see in a moment that the numbers have now all been converted to dollars from floating point. You can download this data, and you can also see the SQL that was generated. So if you have a data scientist, you can then audit the SQL. In the future, you'll be able to edit the SQL. Another question is average daily price of ETH during the last year. It's being sent to the back end, sent to there's an LLM. The LLM converts it to SQL. The SQL then gets executed on our ClickHouse database, which is up to Chainhead, and then displays and returns the results. Here, in a moment, I'll show you some beta plotting capabilities. So you can also visualize the data. Right now, it's semi-manual. So in this case, I need to change it, the x-axis, to show the date. And this shows, so now you can hover over and see the price. So, so this is basically, these are the types of applications that you're going to be able to build on the graph with the SQL data service. And we can go back to the slides. Could someone take the screen back to the slides, please? I can't. Okay. Right now we are in alpha and we're live, and our data is up to Chainhead for those DEXs that I'd mentioned. If you'd like to try it out, please go to agency.xyz, and you can fill out a form. In particular, right now we're looking for feedback from product managers, biz dev, market researchers. We think that the tool could be useful for them. And of course, you may not be interested in DEX data, but we can get other data that you need into the system, including off-chain data. So in the future, the graph is going to also serve natural language queries. So this talk has two parts. It has the SQL part and the natural language part. And after we have incorporated SQL and LLM into the protocol, we will expand from just serving DApp consumers today, which is where our initial product market fit was with the graph, to also being able to serve enterprise customers. And within the graph itself, within the graph ecosystem, what is going to be interesting, I think, is we currently have indexers who are specialized in serving GraphQL queries, but you'll see in the future we're going to have indexers who are specialized in serving high-performance SQL queries, and we'll also have indexers who specialize in serving LLM queries. And in terms of the protocol, in terms of what to expect and when you can start using this, we're done defining a prototype for the SQL API, and we are now working on integrating DPT into our deployment specification. DPT this is a jargon, but it's basically like views of the data that make the data more give you more abstractions of the data and make it easier to query. And we're currently working on that, and we're going to do test deployments by the end of the year with another one of the core dev teams, Pinax, and we'll start sending our queries to one of the core dev teams. And then our goal is to have SQL integrated with the gateway and billing and available for testing within the protocol during Q1 of next year. So that's Semiotic's goal, is to get this, our goal is to get SQL into the protocol as soon as possible. The LLM timeline is a lot earlier. This is a newer effort for us. We're currently evaluating open source LLM deployment frameworks. So this basically means we're working on looking at the software stacks where an indexer could take an open source LLM like Llama 2 and run it in their infrastructure. And then we'll work on the LLM API. So how do we have people send natural language queries to the graph? And then we'll start doing test deployments in early 2024. So everything that I've shown you today is based on substreams and ClickHouse. Both of those are, you can start using those today. You can start learning how to use substreams at this link right here, substreams.streamingfast.io. You can go to substreams.dev and you can see the substreams that people have already written, including some of what I showed you today with our agency demo. And for agency, we wrote, most recently we wrote a Uniswap X substream. And so this substream lets you sync to ClickHouse. And so you could start experimenting with collecting your own data if you wanted to ClickHouse, and then you could start querying it with SQL. You could also use that that last link as a template if you wanted to start working on your own other substreams. So in summary, Firehose writes blockchain data to flat files. Substreams filter and process the flat file data. You can then send that data wherever you want. We are using substreams and ClickHouse to get data available for analytics queries. And the graph is adding support for high-performance SQL queries and LLMs. So I appreciate your attention, and I have time for questions if anybody has any. And also, this is a link to the slides, and you can contact me on Twitter at 0xsamgreen. Could we get a microphone?
Hi, thank you for the talk. For the SQL queries for the graph, will the data be indexed down from like raw state, or how will that work as far as what can be queried? Do you understand my question?
Yes. Currently we are indexing events, and so any event that's submitted by the smart contract is put into the flat files. And so we can extract and process those events, that event info. You're welcome. Any other questions?
Hey, so if I understand it correctly, the SQL and LLM are going to work in a similar fashion as the subgraphs, the GraphQL indexers, right? And how is it going to be possible to verify that the data coming from LLMs and SQLs are correct, because they're like much more complex compared to the events chain, the one we have on the graph,
Yeah.
GraphQL.
Yeah, so the question was about verifying a SQL and verifying LLMs. I'll answer that in two parts. So we have current efforts, and I'd say early efforts in verifiable SQL. And what it looks like is that likely we have a path for verifiable SQL. Likely how I think it will work is, let's say you do a SQL query and you get a result, and you want to verify that result. That will then kick off the computations, the proving computations for that particular result. And so let's say you wanted to say, my protocol has had this much volume over this much time. And you want a cryptographic proof that says, that can prove from the chain to the query that it's all correct. Well, you'll be able to, the consumer or whoever wants the proof will be able to generate a proof for that particular result. So it's basically paying for an audit of that particular result. There won't be, the counter example to that would be proving everything, like proving all queries. That's going to be cost prohibitive. So, and in general, I think that you're only going to want to prove the data if it's a high value result, or like if you're going to do something that could result in a high value, let's say, transaction, or let's say you're using it for governance purposes, you would want to verify the data before making some action that could have some high impact on you. The LLM question is a much harder question, and I can't give you a good answer for that right now, how to verify the LLM outputs. There are companies, teams working on verifiable LLMs, verifiable LLM output. So I know people are working on it. Companies are getting funded to work on this, but it's I would say, much earlier in terms of like maturity of that research. Any final question? Okay, thank you.